Welcome to the 18th episode of Let's Talk About Electric Vehicles. My name is Teresa, I'm an economist, and I try to answer general questions about the e-mobility transition from a scientific and research-based perspective. Aside from the reduction of overall carbon emissions, a big argument for implementing more EVs is to enhance urban air quality. I oftentimes read that worldwide millions of people die every year because of poor urban air quality. So naturally, I wanted to know more about the danger of urban air quality and if electrified transportation has the potential to solve this problem. Today's episode is structured as follows. First, I'll give you a little crash course in urban air quality, health, and harmful pollution issues, so that we all know what different pollutants there are and how much of it is really due to road transportation and so on. Then I have two studies here that investigate the effect of electric cars on urban air quality. One of them is a natural experiment from China, and one of them is a hypothetical calculation from Spain. And then we will hopefully find an answer to the question, can EVs really save people's lives by enhancing the urban air quality? Also, there is a third study from California that does not fit in today's episode, otherwise the episode would be a bit too long. Therefore, I will prepare it as an extension to this episode for my Patreon. So more information about that follows at the end of the episode. Let's start off by, what is pollution? This is almost a philosophical question, as basically any substance can be a pollutant if there is simply too much of it in the wrong place. But when society talks about pollution, it usually refers to either natural or man-made unwanted chemicals or other materials that contaminate the air that we breathe, causing adverse effects to humans' health and the environment. For this little crash course, I solely focused on the effect of road transport, so keep in mind that there's other contributors for indoor and outdoor pollution such as industrial plants, or for indoor pollution, faulty gas heaters, cigarette smoke, paints, and so on and so on. But for the sake of this podcast, we only focus on the road traffic emissions. Typical urban air pollutants caused by road transport are nitrogen oxides, carbon monoxide, hydrocarbons, and particulate matter. Then there is the distinction between primary pollutants and secondary pollutants. The primary pollutants are emitted directly into the atmosphere, and the secondary pollutants form in the air as a result of a chemical reaction between the primary pollutants. The secondary pollutants can even be more harmful than the primary pollutants. A typical example for a secondary pollutant is ozone that builds up within cities usually on hot summer days, but it can also be found on the countryside. Nitrogen oxides play a role in the formation of this ozone. From what I read about road transportation and urban air quality, nitrogen oxides, for example nitrogen monoxide or dioxide, and particulate matter, these two emissions seem to be the bad guys when it comes to vehicle emissions. In combination with sunlight, nitrogen oxides contribute to the formation of ozone, as I said, and in combination with other pollutants, it can cause smog and acid rains. According to the European Union Emission Inventory Report, road transport accounts for 40% of the sources for nitrogen oxide emissions. Long-term exposure to nitrogen alone can decrease lung function and increase the response to allergens. Many large cities do not meet the maximum threshold, especially not along busy roads. As for particulate matter, which is basically dust, I find two distinctions. There is PM10 and PM2.5, which refers to the size. So particulate matter 10 has a diameter of 10 micrometers or less, and PM2.5 is only 2.5 micrometers. And it is also known as fine particles. By comparison, a human hair is approximately 100 micrometers, so it would fit 40 fine particles. The fine particles are even worse because they can be drawn deep into the lungs, whereas larger particles get trapped in the nose, in the mouth, or in the throat. Let's start our journey in Spain. A study from 2014 analyzes the potential air quality improvements through 3 different EV adoption scenarios, namely for 13% electrified transportation, which the authors refer to as the low scenario, or for 26%, this is the medium case, or for 40%, this is the high case scenario. And they compared the pollution in these 3 scenarios with the base case, namely no electric cars. The authors calculated numbers, hypothetical numbers, for the Spanish cities Barcelona and Madrid, where road transport is the primary source of pollution. Both cities currently have severe problems with nitrogen dioxide and particulate matter, which are, as we now know, both related to emissions from gasoline and diesel cars. A few words to how they came up with their hypothetical numbers. They looked at what the vehicle fleet composition looks like in terms of how many kilometers traveled on average, what types of vehicles are on the road, hence how many big cars, how many motorcycles, how many trucks, and so on and so on. And then they looked at how many emissions each type of vehicle produces, and then they summed it up for these 3 scenarios, for the low, for the medium, and for the high electric vehicle share. By comparing the 2 different cities, Barcelona and Madrid, it is very interesting to see that the impact of electric cars on air quality varies depending on the typical traffic situation of this respective city. So why is that? On the one hand, if a city has less traffic in the first place, then the main contributor for pollution is actually something else, such as industrial plants or construction or whatever. So the potential pollution reduction resulting from electric vehicle adoption is respectively small. But also, and this I found very interesting, I haven't thought about it, not all traffic-related emissions come from the tailpipe. Even electric cars produce emissions from tire and brake wear and from resuspension. And the bigger the car segment, the higher the non-tailpipe emissions. Therefore, a city where there's a higher share of trucks, buses, and other big cars will not benefit as much from electrifying as a city where mainly small vehicles are on the street. Let's talk about the results of that Spanish study. Yes. Switching from gasoline cars to electric cars brings significant reductions in nitrogen oxide emissions. The potential reductions for the high EV adoption case is similar in both cities, so 40% electric vehicles on the road could reduce the road transport cost, nitrogen oxide emissions in Barcelona by 27% and in Madrid by 25%. But here comes the first difference between the cities. In Barcelona, there are more industrial plants that also produce nitrogen oxides, and therefore the overall reduction of the entire city is only 11%. And in Madrid, it is 17%. So that was for nitrogen oxides. What about the particulate matter? The effect of the particulate matter reduction was not as significant because it seems as if the particulate matter emissions are mainly caused by non-tailpipe emissions. So the result of the calculation still suggests reductions, but they are just not that significant. In particular, what the authors say is that PM10 emissions, so the larger particles, are almost as high for EVs as for conventional vehicles. There was a reduction potential between 3 and 5%. But the PM2.5 emissions, they come partly from the tailpipe and partly not from the tailpipe, and therefore the potential reduction is a bit higher, namely up to 7%. So yes, this is the first proof that a broader EV adoption could indeed help to reduce harmful pollutants in urban areas, but maybe on the expense of a higher electricity demand. There's a chance that the emissions of the electricity generation are polluting the area around the power plants, and there's a chance that these emissions are even higher than the pollution reduction inside the city thanks to electric vehicle adoption. So in that case, electric vehicles would only shift the pollution from the city over to the area around the power plant, and maybe, after all, produce even more harmful emissions than in the all-gasoline car scenario. For that sake, to test this, the authors additionally looked at one particular natural gas combined cycle plant in Barcelona and calculated by how much the pollution in this area would increase in case of the high electric vehicle adoption scenario. In this particular case, the authors find that there will be a slight increase in nitrogen dioxide emissions, but no significant increase in any other pollutants. Also, in the extension of this episode on my Patreon, I will introduce you to another study that mainly focuses on the air quality of a higher electricity consumption. But first, we continue our urban air quality journey by traveling to China, where the so-called 10 cities, 10,000 new electric vehicles project was supposed to enhance urban air quality. Emphasis on it was supposed to enhance urban air quality. Let us find out whether or not the project was a success. 10 cities, 10,000 new energy vehicles. Did 10,000 new energy vehicles reduce the nitrogen dioxide level in 10 Chinese cities? Well, it's hard to tell because, as a little disclaimer, the desired 10,000 new energy vehicle situation has never really happened. So the EV adoption target of this project was never actually met, and therefore the desired nitrogen oxide reduction also was never actually met. But we can still learn something from that project about the impact of EV adoption on urban air quality. Especially because, in contrast to the other two studies that I referred to today, this one is the only natural experiment. So we are not talking about hypothetical future developments, but rather measuring actual levels of nitrogen oxides with and without a large amount of electric cars on the road transport landscape. A few words to the approach of the study. 10 Chinese cities became part of an EV promotion project in order to increase the share of electrified vehicles on the road. The cities were not chosen because of their nitrogen oxide emission levels. So it was not, for example, the 10 cities with the highest pollution levels, which made it possible to do a difference in difference analysis. A difference in difference analysis compares the development of a treatment object with the development of a control object. Meaning that they took 10 more cities that were not included in the EV promotion project and compared them to the cities that were included in the project. The idea is that the treatment group and the control group are preferably as similar as possible, and the only difference between them is that one of them received the treatment and the other one did not. And the treatment in this case is an increase in the adoption of electric cars. Of course, the authors could just have compared the pollution level before and after the electric vehicle promotion, but in that case, it would have been impossible to tell how much of the development is really caused by electric vehicle adoption and how much of the change is due to other factors. This is why researchers in general like to use the difference in difference approach in such a case. So yeah, this is what the authors did. And they indeed find that more electric vehicles resulted in a decrease in nitrogen oxide level. Of course, they controlled for other factors that might impact the pollution, such as the economic development, the oil price, the number of vehicles on the road, the climate and weather, other air quality enhancing measures like building green space, and so on and so on. But even when taking all of these control variables into consideration, the effect is highly significant. And that is despite only 4 of the 10 cities achieved more than 30% of the EV adoption goals. So not very successful. But I wonder by how much the urban air quality would have improved if the project was actually successful. Nevertheless, as I said, what I like about this study is that it is not a hypothetical calculation, but rather a real-world assessment. But it only confirms what hypothetical assessments have been predicting so far. Speaking of which, there is a third study that includes the effect of electricity generation on urban air quality as well. The area of investigation is California, and in this study it is assumed that all required new power plants are built within the area. Hence, there's no emission outsourcing. I thought that this would be a nice additional content for you to find on my Patreon, but more info about that at the end of this episode. Because now I want to summarize what we have learned in the episode today so far. Gasoline and diesel cars have tailpipe emissions. They emit nitrogen oxides and particulate matter, which are both harmful for human health. Nitrogen oxides contribute to the formation of ozone, smog, and acid rain. Particulate matter, which is basically dust with a diameter of 2.5 micrometers or less, are called fine particles, and they can get deep into our lungs and cause serious trouble. Electric cars don't have tailpipe emissions, but there are non-tailpipe emissions due to brake wear and resuspension, which depends on the size and the weight of the vehicle and not so much on the type of the motor. Yet there is an undisputable potential for air quality enhancement through switching to electric vehicles as main mean of transportation, especially in terms of nitrogen oxide emissions. This was confirmed by both a hypothetical calculation and a real-life assessment. But, more electric cars mean more electricity demand, and depending on where the electricity comes from, it may pollute the air surrounding the power plant. There is another study from California that takes that into account, and I will provide some additional content about urban air quality, including this particular study, on my new Patreon account. Patreon is a platform where content creators can ask for voluntary donations from their audience in order to be more independent and in order to be able to put even more effort into creating their content. If you enjoy listening to this podcast and would like to hear more of it, you could support me by, for example, $1 per month, and then receive some benefits like early access to episodes or access to some exclusive material, like, for example, the second part of this urban air quality episode. If this is not for you, don't worry, nothing will change. I will still provide weekly content for free. The interaction with my listeners after each episode is still my greatest reward. I don't need anything else. We have reached the end of this episode. I hope that I could teach you something new today. You will, as always, find all of my references and contact information in the show notes. And let's talk about electric vehicles again next week. Have a wonderful day. Bye!